primarily I wanted to show y'all what went wrong with the test bench that I tried to do at the last SI session with making a T flip-flop. But in general, there's good stuff here, whether you were interested in that particular session or not, about test benches and programming Verilog with sequential circuits. So the deal was we were trying to make a T flip-flop using Verilog and to test it with a test bench. And I just ran into some problems, and for those of you who were there, the primary problem was that I didn't put in enough delays in the test bench, and so you have to give it enough time to settle. And so when we made a change, need to put in like this hashtag 10 to tell it to wait 10 nanoseconds because it was moving too fast and it wasn't recording the change, and that was the primary problem. So, but in general, when you have your sequential circuit, so this is one for a T flip-flop, we have our input, which is T, and we'll have our clock because we're going to be changing on the positive edge of the clock, and we have our output, which is Q. So T and clock are both inputs, and then whenever you have a sequential circuit, you're probably going to be changing your output in the always block. Now, in order to get this to work with the test bench, there was no starting value for Q, so I needed to give it an initial value of Q, and I did that here. And it's often a good idea to have two always blocks, and one always block is going to figure out what your next state is going to be, and then your other always block is just on the positive edge of the clock. It actually advances the state. In this particular example, we didn't need two always blocks, but a lot of times you do, so I went ahead and put it in. So if you recall how a T flip-flop works, if the input is 1, then it should toggle the value of Q. Otherwise, it should just stay the same. So this first always block says if T changes, and because that's the only time that you'd have to make a change is if T changes. So if T changes, so this is always at T, then if T is 0, we don't really need to do anything, so there's nothing there for that. But if T, so that's if T equals 1, then my next value of Q equals the complement of Q. And then it doesn't actually change until you get to the positive edge of the clock. So always at the positive edge of the clock, then Q becomes the next value of Q. So this is our T flip-flop code. Now if I want to test that with a test bench, I'm going to want to try it out with various different values of T and Q and see what I get. So in your test bench, when you define your test bench, anything that is an input in your main program is a reg, and anything that is an output is a wire. Anything that you have in your main program that's not an input or an output doesn't show up in your test bench. So here I also had this reg next Q because I calculated the value of next Q in an always block, but it was not an input or an output. That doesn't show up in the test bench. I also have in my test bench this integer that I'm using as a counter just to iterate what I'm doing. Then you need to instantiate your simulation, and you'll do that with, you have the name. This name has to match the name of your module, so TFF for T flip-flop, TFF for T flip-flop. So in my test bench I have TFF. Then you give this a name. UUT is just for unit under test. And then if you don't want to bother with a different kind of notation, make sure that you put these in the same order that they're in here. So T clock Q and T clock Q. You don't have to use the same variable name, but whatever is in the first spot here has to correspond to whatever's in the first spot in your main. Then initialize, and I initialized my two inputs to 0. And I put in a delay. I ended up putting in delays all over the place because that was what my problem was. And then $display just displays whatever's in quotes. So it should display test bench begin, and then it'll display TQ. It's just telling you what it's going to do. So if you look down here at the bottom, when it started, the first thing it did was to display test bench begin. So that's right here, test bench begin. And then it just displayed TQ, not the values of them, just those letters. So that just was for the user to know that T comes first and then Q. Then delay 10 nanoseconds. And then I have this always block, and this always block is just always. It's going to keep doing it until I tell it to end. And I put in a delay, I put them in all over the place. And then I changed the value of T, and then I waited 10 nanoseconds. And then I changed the value of clock. Now remember, clock was at 0. So now clock is going to be 1. So I just went from 0 to 1, so that's the positive edge of the clock. So since it's the positive edge of the clock, then I should have something happen over here. So when I changed T right here, when T went to T plus 1, that changed my value of next Q. And then when the clock went from 0 to 1, that advanced the state and changed the value of Q. And then I went ahead and did clock equals not clock again, so that just brought it back to 0. And then we'll have another 10 nanosecond display. You do have to have this 10 nanoseconds display in between the clock cycle. So this is the clock going from 0 to 1 and then back to 0. I tried it without the delay and it did not work. And then it'll display the new values. So if you look here, why was Q initially 1? Q was not initially 1. Q was initially 0, and then T was 1, so it toggled, and it was initially 0, so then it became 1. Okay, and then, and so that was the display. And then it says if counter equals 6, then display done and finish. Otherwise, add 1 to counter. So I think I had counter starting at 0 probably. I usually start at 0. Yeah, counter equals 0. So that was the 0 time. And then, so each time T is going to toggle because I have T equals T plus 1, and you can look and see what Q does. So when T is 0, Q doesn't change. And then when T is 1, Q toggles. And then 0 doesn't change, 1 toggles, 0 doesn't change, 1 toggles. And then counter got to equal 6, and when counter equals 6, it displays done and finish, and that's the end of that.